All right, how you guys doing today? This is Mr. Muscarella coming at you in another Super FRQ video for question number 5. This time we're taking a look at parts I, J, and K. I don't know why we do I, J, K. Maybe it should be I, D, K. I don't know. Here we go. Let's get after these problems. Now in this Super FRQ, again, we've got our function g of x defined as the integral from 1 to x of f of t dt, and the figure that we're shown, the graph of f, is made up of 2 semicircles and a bunch of line segments, a couple line segments. So here we go. We want g double prime of -4, g double prime of 2, and g double prime of 3. Now since g of x is defined to be this function here, so I'm just going to kind of play with this here for a minute. That means, don't forget, g prime of x is just going to be f of x. Right, which means g double prime of x is going to be the derivative at some x value. So when I'm taking a look at these values, g double prime of -4, 2, and what was our other one, 3, when I take a look at that, I just want the slopes at those values. So, you know, that's going to be how those pieces are going to play out there. So when I take a look at the slope at -4, so I go all the way over here to -4, and hey, what's the slope right there? Well, that slope, the slope there is going to be 0. If I take a look here at 2, when x is 2, ooh, we've got a sharp turn there. If we have a sharp turn, that means our function is not differentiable right there. So we're not differentiable at x equals 2. So we can't have a slope where our function has that sharp turn. The other spot we're taking a look at was at x equals 3, and 3 is right here. So that's contained on that line segment, so I want the slope of this line segment right here. And I can use any 2 points I want on there to calculate that slope. And if I do that, I'll just go rise over, run. So that's up 1 over 1. But don't forget, be careful because that line is slanted in a negative downward direction. So g double prime of -3, that's -1. G double prime of 4, that had a slope of 0. And g double prime of 2, that does not exist since g prime is not differentiable there. And I'll just abbreviate that DIFF at x equals 2. All right, so that's all you have to do for part I. Now when we take a look at part J, oh, part J, how I love they. All right, now we've got to find h prime of 4, and if this is our function, h defined to be g of 2x minus 4, we're going to just have to take straight up derivative. So let's just take the derivative of h first. So h prime of x is going to be g prime of 2x minus 4. Oops, don't forget, chain rule. That's right, take the derivative of the inside piece. And the derivative of the inside piece is 2. So I'm just going to write that up front. But don't forget, chain rule, derivative of the inside gives us 2. So now we have that piece right there, and all we have to do is evaluate. So h prime of 2, or no, not 2, 4. When we're plugging in 4, we're going to have 2 times g prime of, let's see, 2 times 4 minus 4. So let's see, that's 4 times 2 is 8 minus 4. So now we're going to have 2. And then g prime of 2 times 4 minus 4 gives us 4, g prime of 4. And g prime of 4, well, what is g prime of 4? So g prime of 4, remember, now g prime of 4, so let me go back up here to this part. G prime of 4, that's just going to be my y value of x whenever at the x value that I want. In this case, I want an x value of 4. And what is my y value? Well, if I look right here, my y value is 4. Or at x equals 4, my y value is 0. So, this part right here, that's just 0. So 2 times 0, well, that's just 0. So h prime of 4 has a value of plain old 0. That's kind of funky. Wow. Now on to part K. Part K says, all right, we've got to find k of x, and it's given by this fraction, g of x over 5x. Write the equation of the tangent line to g at x equals 4. All right, so tangent line. So we're going to need 2 things. We're going to need a point, and we're going to need a slope. All right, so we're going to need those 2 things. Now, I know the point, the x value is 4, but I need to find the y value. And actually, this shouldn't be g. It's typo right there. That should be k. Since k of x is defined to be g of x over 5x. So we want the tangent line to k at x equals 4. So we're going to have the point 4 something. And then I've got to figure out the slope. So let's kind of write down maybe some pieces that we could have. We would have y minus something equals our slope, which we don't know what that is yet, our slope times x minus 4. So that's the beginning of this piece right here. So let's kind of play around with the rest of it. Now, k of x. So if I were to just simply plug in 4, that will give me my y value. So then I'll have a point. So let's go ahead and evaluate that. K of 4 is going to be g of 4 over 5 times 4. We're just simply substituting that right in there. Now, g of 4, let's take a look at what g of 4 is. Now, for g of 4, so I'm going to kind of go up the graph. Actually, we'll just evaluate the bottom part. That's just going to be 20. So g of 4. So g of 4, we actually did this piece in another video. We did this in part A, I think it was. But g of 4 is just going to be this integral right here. It's going to be this area that's formed in this triangle here that's above the x-axis. And just to review that real quickly, g of 4, this way would be the integral from 1 to 4 of f of t dt. And we can find the area of that triangle because we know the base is going to have a length of 3 and our height is 2, which means that would give us a value of 6 divided by 2, so that would just be 3. So my top number here would be 3. So my xy point is going to be 4 and then 320. So I'm off to the races so far. So the last thing I need to do, boom, is just come up with a slope. Oh boy. Yes, let's practice our derivative rules, shall we? Because we've got g of x over 5 of x. So no big deal. Low d high minus high d low over ho ho, or however you remember it. So we're going to go ahead and evaluate k prime of x. So first, let's go ahead and find k prime of x. Ooh, yeah. So the bottom, which is 5x, and then the derivative of top would just be g prime of x. Boom, boom. And then minus the top, g of x, times the derivative of the bottom, which is just plain old 5. And actually, I'm going to move the 5 just out in the front here. Okay, we'll do that. So that's that first piece, low d high minus high d low over ho ho, which is 5x squared. All right, so far so good. Let's see what we got coming up at us next. So let's plug in 4, shall we? So k prime of 4 is going to be 5 times 4, and then times g prime of 4 minus 5 times g of 4. It's a sloppy g, but you guys know what I mean. Over, and I'm going to do this part in my head because if I plug in 4, then I'm going to have 5 times 4, and that's just going to be plain old 20, I think. So 20 squared. Wow, that's a big number. All right, so let's take a look at a couple of pieces here. So 5 times 4 and g prime of 4. So we did that before. I think we found the value of g prime of 4. So g prime of 4, that's just going to be the value of, so let's go back up here to our graph. G prime of 4 is going to be the y value at x equals 4, and we know that part's 0. So that's kind of nice. So this guy right here is just going to be 0. So that means all of this is actually gone. And then minus 5 times g of 4. Remember, that's a g, even though it doesn't really look like it. So g of 4, and we just did that, I think, previously. G of 4, yeah, that's my integral from 1 to 4 of f of t dt. That's just plain old 3. So the top is going to be 5 times, let's see, this part right here is just 3. So I'm going to have 0 minus 5 times 3, so that's going to be 15, if I did my arithmetic correctly. So that's going to be negative 15 on the top, and then the bottom is going to have whatever 20 squared is, which we know is going to be 400. Now you can leave it there, and you don't have to simplify that at all, and you could actually just put that in. But of course, you know, we'd like to simplify and practice our algebra skills. So negative 15 over 400, and then when you reduce that, 5 goes into both of those, so that's going to end up with negative 3 on top and then 80 on the bottom. So you could just leave it as negative 15 over 20 squared and substitute that little puppy in for the slope, and you'd be good to go. Or you could reduce it all the way down to negative 3 over 80. For the purposes of the AP exam, either one gets you the point. So negative 3 over 80 is what our slope is. So the equation of our tangent line K at x equals 4 is equation y minus 3/20 equals negative 380 times x minus 4. You don't need to show off and put that in standard form or anything else. You could just leave it right there. A lot of times, and this will come in handy maybe in BC later on, you might write it in Taylor form. So you'd move the y value over and put 3 over 20 minus 3/80 and then x minus 4. Either one of those would be okay, and you could change that to slope-intercept form if you really, really wanted. Just be careful on your arithmetic on that, because that's where most people make a mistake. And if you do make the mistake, then you throw away the point. Ain't nobody want to throw away the points. So that's all you got to do for this one. All right, so take your time with your arithmetic. Just know that you got to find the point and the slope, and you're good to go for part K. All right, that's it for this video. Thank you, Mathletes, for watching, and I will catch up with you later on. Peace out.